Good day, grade 9 mathematicians. Right, we are going to deal with a topic under Pythagoras theorem, and this subtopic is all about identifying right-angled triangle. So, in other words, here we are looking at triangles, right? Then from these triangles, we must find out whether the triangle is right-angled triangle or not. Now, in order for us to do that, we are going to make use of Pythagoras theorem. Now, if you still remember from the previous lesson, under Pythagoras theorem, I said Pythagoras theorem is an idea which is used on right-angled triangle, right? In other words, this theorem is only true if the triangle is a right-angled triangle. However, we can use this idea to identify those triangles that are not right-angled triangle as well, right? But it's so good to use Pythagoras theorem, especially if we are given a right-angled triangle. Now, how do we identify right-angled triangle by using Pythagoras theorem? Right, we are going to look at how we can make use of Pythagoras theorem to identify right-angled triangle or those triangles that are right-angled, right? Now, so you're going to do exercise 11.3, that's on page 129, and the questions that you're going to answer is question 1, 2, 3, and 4. Now, I have an example here that we are going to make use of so that we understand how to make use of Pythagoras theorem to identify right-angled triangles. Now, so we are given triangles in the form of sides and their measurements, right? So you can draw the diagram and put in the information, right? It's not a problem. But we can as well make use of the information without drawing a diagram, right? So in this case, we are going to make use of Pythagoras theorem, especially on question number 1.1.1 and 1.1.2. That's where Pythagoras theorem is very, very important for us to deal with those problems. Then question 1.2, it doesn't deal with Pythagoras theorem. However, but at times we might be asked to find one or two sides there so that we can then calculate perimeter or area. But in this case, Pythagoras theorem is not important for question number, or on question number what? 1.2. It's just part of a question that we are going to deal with so that we know more about a triangle. Right. Now, before we deal with the problem, a reminder, right? This is from the previous lesson, right? So I've just written here, remember, right? On the top left-hand side corner here, remember, right? Or please note that if we are given a triangle ABC with angle B equals to 90 degrees, then, right? So this is the triangle that we are given. So we're just using it as what? For explanation purposes. So this is the triangle on my right hand side top corner of my screen. It's triangle ABC. Remember, the symbol for a right angle is this corner or a square of some sort, which is written on vertex B. This is the symbol for 90 degrees. It means AB is perpendicular to BC. Or in other words, it means side AB is 90 degrees to side BC. In other words, AB is a right angle to what? BC. That's the side, right? Now, given a triangle ABC with angle B equals to 90 degrees, then 1. By Pythagoras theorem, it means that 1.1. The square of the hypotenuse side is equals to the sum of squares of the other two perpendicular sides, right? In this case, I included the word perpendicular here just purposefully, right? The reason why I put this is a reminder to say Pythagoras theorem is very, very important, especially if we are dealing with the right-angled triangle. We shall make use of this Pythagoras theorem a lot in mathematics, right? Fine. So it is the sum of squares of the other two perpendicular sides, right? So which sides are perpendicular? We have got AB and BC. These are the two other sides which are perpendicular. And which one is the hypotenuse side? The hypotenuse side, if you still remember from the previous lesson, I said hypotenuse side is a side which is opposite 90-degree angle, right? So in this case here, we are saying AC is the hypotenuse because it is opposite 90-degree angle. Now, instead of using this definition for Pythagoras theorem, instead of using a hypotenuse side, we can make use of the longest side. Right? Remember, the hypotenuse is the longest side because it is opposite 90 degrees. Then instead of using words like the two perpendicular sides, we can make use of two shorter perpendicular sides, right? Remember, we are saying the longest is opposite 90 degrees, which means the other two sides are shorter than the longest side. So we can make use of the first definition here. The square of the hypotenuse side is equal to the sum of squares of the other two perpendicular sides. Or we can say the square of longest side is equal to the sum of squares of the two shorter perpendicular sides. These statements are just one and the same thing. It's just that we've just used different words here. Fine. Then these two statements can then be represented by the equation that I have written here in terms of what? Sides, right? AC, this is one side of the triangle AC. Remember, a side of a triangle is represented by letters on the vertices of the triangle. So side AC, this is the longest or the hypotenuse side or the side opposite 90 degrees, right? So AC squared is equals to the sum of the two shorter perpendicular sides. It's AB squared plus BC squared, right? It's just one same thing here, but it's now written in mathematical form. Now, then this is just a reminder, remember. Then number 2, perimeter. Perimeter of a triangle ABC, right? Whenever we are to calculate perimeter, remember perimeter is just the distance right round the shape. So the distance right round a triangle, it means we are looking at what? 3 sides, right? So each side has got its own length. So we are just saying is the sum of the lengths of the 3 sides. You just add those sides, which means according to this triangle that we are given, we'll then just say first side AB plus side BC plus side AC. This is the perimeter. So it's the distance right around the shape, right? This is just a reminder. Fine. Then number 3, area of triangle ABC. We are using this triangle that we are given, right? And we are informed that the triangle is right-angled triangle. So the formula for a triangle, in this case, we are dealing with right-angled triangle. We shall be dealing with triangles that are not right-angled triangle, right? So get me right there. So for now, we are dealing with a triangle which is right-angled. So to find area, it's very, very easy for us if we are dealing with the right-angled triangle. So, but by definition, area of a triangle is equals to half 1/2, which is half, multiplied by the base side length, or we are just saying that we multiply by the length of the base side times the height of the triangle. Right. How high is our triangle? So there is going to be a line that represents the height of the triangle. But by saying a height, it's not always that the height is in a vertical position, right? It depends on the position of what? The base side. Again, the base side is not always the case that it is at the what? Bottom, or is what? The base side, right? You may find out then that the base might not be at the bottom, might be on the side, or might be at an angle, right? So these are just words or terms that are used so that we identify those sides from the triangle. So we've got a side that we refer to as a base side, and a line or a side. In this case, for right angle triangle, we have a side that we are going to refer to as what? Height. So these two, base and height, can be interchanged. Especially for right angle triangle, we can interchange them, it's not a problem. So please note again this statement which is written in red. Base side is 90 degrees to the height of the triangle, right? Then I've just substituted using triangle ABC. I've just substituted the base side. I've taken base side to be BC. And BC is perpendicular to what? AB. So it's half times BC times AB. Right. Instead of saying base side it's BC and the height is AB, someone can say, fine, my base is what? AB. Like I was saying, it's not always the case that the base is always what? On the horizontal side or at the bottom, right? So someone can take AB to be what? Base side. Why? Because it is perpendicular to BC. So AB becomes the base and BC becomes the height of the triangle, right? This is right angle triangle, so it's not a problem. As long as we are having a side which is perpendicular to the other, then we can interchange the vertices of the sides. It's not a problem, right? Fine. So then from there, I've just substituted, then we have got half BC times AB, or it's half AB times BC. We can what? Commute them, it's not a problem since it is multiplication. Right, so that was just a reminder. So these formulas are very, very important. We shall be using them in our future problems, right? Now, let us now go back to question 1.1.1. We want to find out whether this triangle is a right angled triangle or not. Now, so what we are going to do, in order for us to make use of Pythagoras theorem, the first thing that we must do is to identify the longest side. We must identify the longest side, then the other two sides, right? Since Pythagoras theorem deals with the longest side. So if you can just check here on 1.1.1, which one is the longest side? The first side is LM, which is 10 centimeters. The second one is MN, which is 12.5 centimeters. And the third one is LN, which is 7.5 centimeters. So it means my longest side is equals to what? MN, which is 12.5 centimeters. So we are now going to answer the first what? Question. Solution. Or it's just what? Answer. Now, question 1.1. Like I said earlier on, I'm going to identify the longest side. My longest side is equals to what? Like I said, it's my longest side is 12.5. And what side or which side is it? It's MN. My longest side is equals to what? MN, right? Which is equals to what? Which is equals to 12.5 centimeters, right? Then here I'm just taking a note of the important information. Then the two other sides, sorry for it there, it's supposed to be two other sides. Two other sides, I have what? My two other sides, I have the sides such as LM and LN. LM, which is equals to 10 centimeters, and that's LN, which is equals to 7.5 centimeters, right? So this is the information that I have, or from the statement. Now, I'm now going to make use of the Pythagoras theorem now. What does Pythagoras theorem say now? Right. Our Pythagoras theorem, allow me to start from there. Now, if the triangle is a right-angled triangle, it means it will satisfy Pythagoras theorem, right? So, in other words, I'm going to use Pythagoras theorem to prove that the triangle is right-angled, or to prove that the triangle is not right-angled triangle, right? Now, by Pythagoras theorem, allow me to start by that. I'm just redefining Pythagoras. By Pythagoras theorem, we are saying longest side, that's square of the longest side is equals to sum of squares of the other two perpendicular sides. Remember I said last time that I'm using the word perpendicular purposefully, right? Perpendicular sides, right? Then now, which one is my longest? Remember I said my longest is what? MN. So it means mn, I'll put the square later, is equals to the other two sides, lm squared plus ln, right? So in this case, remember I said we are supposed to be dealing with what squares. So let me then put the square before I forget. So its longest side or the hypotenuse side is what? Mn. Then the other two sides are Ln and Lm and Ln. Right? Then from there, from the definition, I put symbols. From symbols, then I substitute. Mn squared is what? Is 12.5. 12.5. I will square it later. Must be equals to Ln, which is 10 centimeters, right, plus Ln, which is 7.5 centimeters. I'm just substituting here in our symbols. So which means I'm going to square 12.5. That's the squares. Now, since I am to prove or to show that the triangle is either right angled or it's not right angled, I'm not going to transpose anything, right? I'm not going to transpose anything in this case. Remember I said if the triangle is a right angled triangle, it will satisfy what? Pythagoras theorem. If it doesn't satisfy Pythagoras theorem, then it means it's not right angled triangle. So I'm not going to transpose anything. So the right, whatever we have on the left hand side must be equal to what we have in the right hand side. Now, let's quickly then calculate what 12.5 squared. From my calculator, 12.5 squared, I will come up with 156.25. 156.25. This is equals to, then 10 squared. 10 squared is 100 plus 7.5. Again, what is the outcome there for 7.5? It's 56.25. 56.25. Now, then remember I said I'm not going to transpose anything, right? I'm just proving, right, that the triangle is either right angled or not right angled. So I'm going to just copy what I have on the left hand side. It's 156.25, which is equals to, and 100 plus 56.25, I'll get 156.25. Now you can see here that the left hand side is equals to the right hand what? Side, which means now that Pythagoras theorem has been what? Satisfied. Therefore, it then means that, oh sorry, therefore triangle, my triangle I'm just drawing this symbol for a triangle. This symbol is very, very important. We shall be using it a lot. Right? Mathematicians use a lot of symbols. Right? So therefore, triangle LMN, right? This triangle LMN is right angled triangle. Let me just write the word. It's right angled what? Triangle. Then why are we saying it's right angled triangle? Right? We are saying it is right angled triangle because Pythagoras theorem has been satisfied, which means we are then going to say mn squared is equals to lm squared plus that's ln squared. This is the reason why we are saying our triangle MN is right angled triangle. Why? Because Pythagoras theorem has been satisfied. In other words, the left hand side is equals to the right hand side, or the longest side is equals to the sum of squares of the other two sides. So for this one, we are done. Then let us now move on to, let me just finish this one now by putting a bracket there. I'm closing the bracket. This is the reason why we say this, it is what? Right angle. Then let us move on to the second one. Now for the second one, right, we are given a triangle. The triangle that we are given, again, we are going to make use of the same method, right? Allow me to move on to the second. Let me move on at the page here. Right. So our second question, 1.1.2. Right, again, I'm going to use the same method. I'm going to identify what? Longest side. Longest side, which is equals to the longest side of the triangle, according to the information that we are given there. We have got xy, which is 2.5 meters, yz 1.6 meters, xz 2 meters. So it means the longest is 2.5 meters, which is xy, which is equals to 2.5 meters. Then the other two sides, let me shorten it by just saying two other sides. My two other sides, we've got yz, which is equals to 1.6 meters and xz, which is equals to 2 meters. Now, remember on 1.1.2, on 1.1.1, we have already defined Pythagoras theorem. That's the longest is equals, the square of the longest is equals to, let me just write that one, right? The more we write the definition, the easier it will be on our side to be able to recall it. So it's the square of the longest side is equals to sum of squares. Perpendicular sides, right? Now, and then from there, I'm just going to make use of the size that we are given in the statement. The longest one, we have identified it to be what? Xy squared must be equals to yz squared plus, these are the other two sides now, xz, right? Then from there, just putting the squares here. Then from there, I'm going to substitute the measurements that we are given. So our longest side is 2.5. We square it, equals to yz, which is 1.6. Again, we're going to square it. Then we have 2. We are also going to square that side. So now 2.5 squared, what is 2.5 squared? Then again 1.6 squared, 2 squared. Now 2.5 squared, we're going to come up with 6.25 when you square that one. Then 1.6 squared, we are going to come up with, for my calculator, I'm going to calculate that one. 1.6 squared, we have 2.56. And then plus 2 squared, which is 4. Then remember, I'm not going to transpose any number because I'm just proving here. I just want to prove the triangle to be right angled or not right angled, right? So if it satisfies Pythagoras theorem, it's right angled. If it fails to satisfy Pythagoras theorem, it's not right angled. So it's 6.25 equals to, then 2.56 plus 4, we come up with 6.56. Right? Now, if you compare the left-hand side and the right-hand side, you can see there that the right-hand side is not equal to the left-hand side. Therefore, since the two are not equal, let me then put this sign to show that the two sides are not equal. These two values are not equal. So since they are not equal, it then means that Okay, then therefore a triangle triangle XYZ is not right angled triangle. Why are we saying it is not right angled triangle? It is not right angled triangle. Why? Because the longest side XY is not equals to, right, is not equals to the sum of squares of the other two sides. That's the reason to why we are saying it's not right angled triangle. So I put here, cross that since it is not equal. The square of the longest side is not equal to the sum of squares of the other two sides. Right. Then so it means we are done with the first two questions. Then we move on to question the second one, which says here, let me just go up and check the question. 1.2. 1.2 says calculate perimeter and area of triangle LMN. Right. So by definition, remember by definition, perimeter on point number 2 here is equals to the sum of length of the three sides. Right. So we are just going to find what the perimeter there by using those dimensions. Please note we are making use of triangle what? LMN. So 1.2, the perimeter of triangle LMN is equals to, remember it is equals to the sum of side lengths of the triangle. Oh shit. Sorry, I was just deleting everything now, of which I was not supposed to do that. Let me go back to where I was right here. I was saying here, so let me just use backspace here. 1.2, the perimeter of triangle it is equals to sum of length side lengths or sum of the three sides of the triangle. Right? Then, since we are talking about the triangle here, right? Then I'm just going to substitute. If you still remember, we have three sides, which is equals to the three sides that we have there. Let me just go back to the information and check the information. So we said LM, we have side LM plus side MN plus LN. We are just adding the three sides. Sorry for that one. It's a small letter, which is not a vertex. Whenever we are dealing with vertices, we normally use capital letters, not small letters. If you use small letters, then it will mark the wrong. Right? Then its LM is 10 centimeters plus, then we have MN, which is 12.5 centimeters plus we have LN, which is 7.5. Something happened again. I did not take note of what is happening there. Right, so we had the first one being 10 centimeters, the second one being 12.2, and the third one being 7.5. So when you add the three, 10 plus 12.5, it gives you 22.5. 22.5 plus 7.5 becomes 30 centimeters. So that's the perimeter there. Right. Then from there, we are going to calculate area. Now, area of triangle. Unfortunately, I don't have the symbol for a triangle from this program that I'm using, so it may take me a long time to keep on switching. Right, area of triangle. This is the triangle what? It's triangle LMN, right? Then remember the formula for area of a triangle. We said it's a half. That's half multiplied by the base side, or the base side length, or the length of the base side multiplied by the height of the triangle. Now, if you still remember the triangle that we are dealing with, it's a right-angled triangle. So since it is a right-angled triangle, we are just going to identify one side as the base and the other one as the height, right? We can make use of the two interchangeably. In this case, the hypotenuse side or the longest side is not going to be used here, right? Because it's not perpendicular nor what opposite, sorry, it's not perpendicular to any of the sides, so we're not going to make use of that hypotenuse side or the longest side, right? Then from there we are going to substitute now what is going to be the base. The base, let the base be equals to, we have our base which is Lm, or we can make use of what, Ln, right? Ln multiplied by Lm, right? Which means the height is Lm and the base is what, Ln. But we can make use, we can use these interchangeably. We will still come up with the same what answer, since multiplication is commutative, right? Which means it's going to be, I'll put a half later, times Ln, which is 10, Lm is 7.5, multiplied by 10, which is Lm. Then we just simplify that. Right, remember it's 7.5 centimeters times 10 centimeters, right? So we are multiplying centimeters twice. So half times 7.5 times 10, we are going to come up with what? That's, let me then just quickly calculate that using my calculator. It's 7.5 times half of 10, which is 37.5. Then it is square centimeters. Why are we putting the square? The square simply means we are multiplying centimeter twice. So it becomes 37.5 centimeter squared. So this is how we calculate area, right? So as a recap, our idea here, or the major issue that we're dealing with, is to show or to prove that certain triangles are right angle triangles and some certain triangles are not right angled triangle. So if we are to identify a triangle as a right angle triangle or not right angle triangle, that triangle, for it to be right angled, it must satisfy Pythagoras theorem, or number 1 here. Right? Failure to satisfy Pythagoras theorem, it means the triangle is not right angled triangle. Thank you. So may you now do more practice on exercise 11.3. You are finding out whether the triangle is right angle triangle, or you are proving whether a triangle is a right angle triangle or is not a right angled triangle.